In the world of life sciences, innovation can't wait for the long lead times of traditional manufacturing. The challenge? To create complex, large-scale equipment quickly and affordably. The solution is to build it differently.
My name is Harry Epping. I'm a manufacturing process engineer here at AFYS3G in Emmen in the Netherlands. The core business of AFYS is manufacturing of equipment for the life science industry. That means that we produce machines regarding capping and decapping tubes, scanning and engraving codes for these tubes, and for these purposes we manufacture equipment. We had the need to have a big, large format printer for printing housings for our equipment. And we didn't want to invest in large amount of tooling for like die casting, injection molding, vacuum molding. So that's why we thought that 3D printing would be a good alternative for manufacturing these parts for our equipment. Here we have this 3D printed housing, which is almost ready for post-processing. Before we send them out to post-processing, we assemble it so that we check if all the parts are there, if all of it fits and all of the parts are a little aligned. And if this check is done, we send it out to post-processing. And after post-processing, it takes only almost 3 weeks. It comes back here at our facility, and then we're going to assemble it again. And then we do the check, and then it's ready for the assembly. So what you see here, we have this 3D printed part which is post-processed in a white color, also a little bit textured. We have this frame here, which is also a 3D printed file, painted in a high gloss black paint. Quality what the printer could deliver, and also the accessibility and the way how to use the printer was a very large topic for us, because we see the printer as a device, as an enabler. It's just a production device, and we didn't want to fiddle around with tweaking all kinds of parameters. So what we send out should come out at the printer. That was one of our main challenges for choosing the right printer. At the end of the day, we decided still to purchase the Studio. For our purposes, we thought that this, because of the footprint of the machine and also the possibilities to use the closed cabinet for fume extraction. Currently printing in a top cover of the housing. The material we use is still purely high temp from BigRep, and we have the ability to also monitor the printer's remote by using Connect. The biggest challenge is to reduce the lead time, the production time of the print. Our idea is that we want to have the production of the 3D printed parts and also the mechanical parts in sync. We have some parts on the machine which takes only 2 days, but there's also a part which takes almost 6 days for printing. So, and in the meantime you can use the printer for anything else. So we decided to purchase another printer, the second one, to reduce the lead time of the printing time. Most of the parts are post-processed, so we send them out for painting. So they will be sanded, filled, sanded again, and then painted in the right color. And also we apply some paint with some structure on it. And internal parts which are not visible, we don't do anything at post-processing besides applying some inserts if necessary. And you see at the end result, it's almost like an injection part or a die casting part or a vacuum part. It's from the outside you can't see if it's 3D printed part. You also could decide to manufacture parts in a traditional way, like milling and machining. But printing is much faster and also cheaper than the traditional way of machining these parts. We also have to always keep in mind the function of the parts and the strengths and the stresses which come on these parts. But if they're is the possibility to 3D print these parts. We will take this chance to 3D print. We use the 3D printing technology for almost everything where it's applicable. In the past I went to a kind of a symposium and there was this topic beyond 3D printing, because everybody was printing flower vases and leprechauns for in the garden. But that's a stage we are beyond, because 3D printing is much more mature. 3D printing is here to stay, as I say it. I think it's a more adapted technique for many industries, and also because of the materials which also are evolving. I think that's something, it's a valuable production technique.